So what I need is just keep an eye on this. Just make sure that I'm still in this. The slides are going the way they should. Okay. And then this is kind of where the chat's going to be. But we'll check that at the very end and see if people start putting stuff in there. So
do you not want me, if a question pops up, to...
I don't know, like we might be interfering with each other because I have to have the control of the slides, that's all. So,
okay, gotcha. So, yeah. So don't touch it.
Yeah, so I'm going to, where is it? Where is my... Perfect. We'll just... Alrighty, ready to get started?
Sign in list?
Yep, right there. All right, good morning, everybody. Let's let the last couple of people walk on in, and then please sign in, guys. Has everybody signed in? Everybody who wants to volunteer to sign in? Okay. All right, sign in, guys, and then go ahead and get something to eat, grab some coffee. There's water and soda and stuff like that in the cooler. We'll go ahead and get started. I don't know, for those of you who are on live stream, thank you for attending. We'll go ahead and get this thing rolling. All right, quick thing. I just want to make sure everybody in the back can see. Hey, Matthew, can you tell me what's on the screen? Yeah, legibility. I just want to know that everyone can read it from the back. Can you read it? You didn't fall for my trap. Okay, no worries. Perfect. All right, well, today especially I want to give a quick shout out to our sponsor, Liberty Firearms Institute, who's been kind enough to let us use their facility. Just in case, obviously they told me, I asked them if they wanted to show anything. Starting tomorrow, they're doing a 15% off their membership, so I wanted to give a shout out to them on that if anybody would be interested in. And I also want to give a shout out to the two companies that were catering. Lunch today will be catered by Turnbull Barbecue, and then this morning, all the spread you see out here was brought to you by Liberty Wing Services. So just want to say thanks to them. Obviously, they're not here, but they'll know in spirit. So moving on. Okay, so one of the things is this something we're going to do differently this year than what we've done in years past. Quick show of hands, how many people have been here before? Oh, okay, just a few of you. All right, mostly new people. How about anyone online? Okay, I can't tell. All right, so this year we're going to do something a little different. So everybody who did go last year or the previous year that didn't show up today, they miss out on this. So we're going to do, and we'll see if this actually works. No, it's just, I hate YouTube sometimes. All right, so what we're doing is, for those of you who stay till the end, we're going to do a Jeopardy off, right, where we're going to ask you a couple of questions about what you learned here today. First place winner gets a gift certificate to shoot the Gatling gun here. So, yeah, exactly. I was going to show you what it's going to look like, but of course, you know, technical stuff never really works the way you want it to. So. All right, come on, work for me. All right, we already started the stream. This is the schedule for today. So basically, right now, obviously, we're getting started. Hey guys, if you can sign in real quick, when you just make sure you just put your name down. If you have to flip over to the next page, we're just trying to make sure we got everybody who attended. So first is going to go with me. We're going to provide a lot of breaks. Obviously, what I used to be in the Army, we used to call it death by PowerPoint. Nobody likes that. We like sitting and just watching a PowerPoint slide going over and over again. It's like back in the day. I don't know if you guys watched South Park, like the guy who was the serial killer who was trying to show Cartman, you know, all of his slides from his vacations. So nobody likes that. So we're going to take a lot of breaks today. First starting with filters, then we're going to go to belts and shivs, then we're going to go to bearings and motors, and then finish up with HVAC coil cleaning at the end of the day. Feel free to ask any questions at any point. Silence your phones if you can. I don't want to be the first guy to have that problem. And then let me know, feel free at any point to just shout out a question. For those of you who are online, go ahead and shout out, put it in the chat, and we'll answer it as soon as we can. So I won't be offended. If some of you guys have to leave today, I won't be offended or anything like that. I get it. You guys got stuff going on. So, all right, moving on. Starting with air filters. Okay, my name's Josh Johnston. Most of you probably know me, or at least three or four of you do. I am a TSM for Camfil. I'm the filter guy. So everything, just so you're aware, everything here is going to be related with the companies with us and the companies that we work with. So we don't intend for this to specifically be, hey, you have to buy this product, but just so you are aware, everything, all the knowledge that we're bestowing is based off the products that we sell. So I just had a couple of comments last year that they felt like this was like a sales pitch. It's not a sales pitch, but the only information I have is on the product that I sell. So, but I will do my best to answer any questions you guys have. Okay, for me, what we're going to start off with is just a quick thing, some filter nomenclature, just some of the things to make sure that we're on the same page, so you guys know kind of what I'm saying. If I say, pleat, or if I say mini pleat or something along those lines, you know what I'm talking about. And then we're going to move on to an air filter review. For those of you who've been here before, you'll already know, a lot of this stuff, but basically this is just going to kind of go into the basics of air filtration. And then we'll move on to this, right? While most of you guys are my customers, and so the big question that we want to answer is, why the heck are you spending so much money buying Camfil? That's what I want to give you. I want to give you guys the tools in order so you understand that. After the fact, we'll go out and we'll do the cam tester. A lot of you guys have probably seen it. It's my big device. It's a pretty cool show. That will be in the break time, so you don't have to come out and attend. So you can go make phone calls, do whatever you need to do. But we'll be doing that probably about 9:30, 9:45. I have a tendency to go faster when I actually do this. So, all right, starting with nomenclature. Okay, so everybody's familiar with this. This is the most common one, right? This is what we call pleat, okay? It's also called a panel filter. So if I say pleat, it's usually because it's a woven kind of a mesh fabric that's been squeezed down into a cardboard box. That is what we consider a pleat. A mini pleat is basically the same thing, but it utilizes smaller fiberglass material and fiberglass media, of which case these can have a higher MERV rating to them. We'll get into that a little bit. But oftentimes they're not used for pre-filtering. Does anyone know why? Just out of curiosity. Has anybody tried to use one of these to pre-filter? Okay, does anyone know why you shouldn't use one of these to pre-filter? Usually you can get like a MERV 15 out of these if you do it right. Well, I say if you do it right, if you buy one. Any idea? All right, so just quick thing. So the reason why you primarily use these as your pre-filter instead of these is because of the variability, right? You have far more surface area, and you also, far more surface area, far more area for air to flow through. Okay, so if you take like a leaf or something along those lines, because the area for air to flow through is so much smaller, it can blind these really easily. Okay, a leaf coming in through here and kind of blocking up doesn't really do a heck of a whole lot. You also have a lot of extra protections out here to keep the air from flowing through without having to worry about it preventing the airflow, I guess. Anyways, so moving on. All right, V-bed filter, that'd be this right here. Basically, these are mini pleats that have been put into a V-bed fashion. Primary reason for that is so that you get better airflow, get more volume, and you can get more pleats in there, right? So the pressure drop on this one, what is this? This is a MERV 13. Well, you're probably looking about the same. So the pressure drop on this is about 0.5. The pressure drop on this is also about 0.5. But this has double the amount of filter media in it, which means its overall lifespan is longer, right? So that's the reason why they basically took this technology, put it into a V-bed type fashion, and it extends the life and it extends and it reduces the overall impact on your fans. Bag filter, also sometimes called a sock filter down there. For those, I guess for those of you on live stream, there you go. Basically, what this is, the benefits of using these is because the fact is that they don't get blinded easy. They have high MERV ratings. You can get them all the way up to like a MERV 15, and they're very good if you have like really dirty environments. LCCC, right? This is what you use in your welding shop, right? So they're really good for really dirty environments. They also can handle water, while pleats usually can't, and we'll get into that. But they're a good kind of all-around filter if you don't have something that requires pre-filter. So certain, specifically like hospitals, you guys have certain codes and stuff like that. But these can have exactly the same MERV rating as these without having to be pre-filtered. So some cool aspects about that. Carbon filter, I don't have a carbon filter here with me, but carbon filter is primarily utilized for like scents and things like that. It can actually grab up the gaseous molecules in the air. A lot of times, Boulder Water Treatment Plant, are you guys here? No, I guess they didn't make it. Okay. But basically, they use it a lot of times because especially when you get the foul smell from the sewage and stuff like that going through the air ducts, it basically captures all of that scent and sort of keeps it in. That's primarily what carbon is used for. Is anybody from Longs Peak here? Longs Peak Hospital? Nope. Okay. All right. Well, then we'll move on. Metal washables. I'm not going to spend too much time. Basically, they're metal. They can be washed. They're really good to help prevent things like cottonwood media or cottonwood, excuse me, if you have a bad cottonwood problem. One thing though is, does anybody have any ideas on how you get the cottonwood out of this? Out of the cotton out of a metal washable? Anybody know? Any suggestions? Okay, I'm not making this as a recommendation. Oh, did somebody know? Yes. Okay. Yeah, that's the only way I found out. Okay. The only way you can get cotton out of these things, you can't seem to blow them out. You can't seem to spray them out. I don't know why, but if you take them into a nice, safe location, okay. Disclaimer: I'm not advising this, but you can light the cotton on fire, burns it all out, and you can put the thing back in the air handler. So, have you tried it? No. Are you willing to admit that you've tried it? Okay. We'll move on. All right, nomenclature. Okay, one of the things I just wanted to bring up. So, nominal versus exact. So, does anybody, just offhand, can anyone guess what size this is? No, it's 23 3/8 by 23 3/8. All right, that's what we mean by nominal, right? We utilize the name, right, to describe what it is, right? It's the term to describe, but everything has to be undersized, because if this was the same size as your filter rack, what would happen? Yeah, you wouldn't be able to fit it in, right? You'd have to crush it. So it has to be slightly undersized in order for it to work, but you need to know what the size of the opening is. So this is what we call nominal. Obviously, exact is usually something that we use for custom filters. I guess this isn't custom, it just looked like it was. But basically, custom filters would be built to the exact specifications. So, for example, I work with and maybe they're online, I don't know. I work with a hospital up in Wyoming, and they actually had some pre-filter banks that were exactly 24 by 24. So we sent them a whole bunch of nominal size, and then they were too small. Doesn't happen very often, but there is those occasions, right? If you have any kind of fan coil unit filters or anything like that, those usually have to be customized to the exact dimensions. But any questions on that? So you got a scowl on your face. Do you have a question? Oh, okay. All right. So, perfect. HEPA filters. Does anybody offhand know what HEPA stands for? It's an acronym. Anybody? Come on, Kirk. You should know this. All right. It stands for High Efficiency Particle Arrestor. Okay. So HEPA filters are, and I don't have one up here with me, but HEPA filters are a high efficiency filter to the degree that it filters out the smallest of particulate in the air. Okay. So oftentimes we'll get requests for something that looks a lot like this, and they'll say, I need a HEPA filter that's a MERV 13. And part of the reason I'm bringing this up is because this happens quite a bit. There is no MERV 13 HEPA filter, right? HEPA filter goes outside of ASHRAE standards, outside of the MERV ratings, and basically gets to a point where it's above 99.99%. So if somebody needs that kind of filtration, hospitals, right, for operating rooms, pharmaceutical companies, those are places that you need 99.99%. But just because it looks like a HEPA, or because maybe somebody requests a HEPA, oftentimes you don't necessarily need it unless it's a really crucial area. But that's what you're primarily looking at. These also come in both nominal and exact dimensions. Looks like I already put that up there. Greeley Hospital. Anybody here from Greeley? Okay. All right. We have some experience with that. So, all right. Now we'll go ahead into the air filtration review. So this is just kind of going into the basics of air filtration. Does anybody know why we filter the air? I mean, of course you guys know. Like, you guys are professionals. Can anybody give me a reason?
System efficiency.
System efficiency. What would make filtering the air more efficient?
You're eliminating restrictions on the coil. You're limiting how much that motor is having to work. So you're increasing the efficiency by eliminating restrictions. So if your coil is restricted, everything's gonna work harder.
Okay. Are you saying that it's restricted because if it's like full of gunk?
Yeah, right.
Okay. Oh yeah, yeah. Then that's absolutely right. Right. Part of it is you want to protect your HVAC equipment. Yes, exactly. Right. Your coils. If you didn't filter the air at all, basically all the junk that comes in from outside goes straight into your coils and just makes everything a mess. Your coils get clogged. Your motors have to work harder. Your belts end up getting working harder. What else? Does anybody else have any ideas? There's a couple of them.
Indoor air quality.
That's true. Absolutely. Yes. So that'll be the last one. I've got another one here. Basically, keep the ductwork clean. I work with a cement company that had a bunch of really, really fine dust. And when it would get up into the ductwork, basically it would set off all the fire alarms. So depending on what kind of dust, what kind of manufacturing you do, anything like that can get up there. You can potentially have a fire hazard, right? Protect the facility, okay? That could be anything. That could be just like electronics that you have in the building. It could be whatever you're necessarily working on. It could be equipment, stuff that you just don't want to get crap from the outside on your stuff. And then protecting a process, right? So JM Smuckers is one of my customers. They want to make sure that you guys don't have sand in all of your uncrustables, okay? That kind of stuff. I don't know if they try that hard. I'm not sure, but I'm just joking. Justin, you're not here, right? Okay. All right, and then the last one, you're correct, indoor air quality, protecting everybody. Okay, so with that said, we know that we have filtration and we have to have a certain level of it in order to make sure that that people inside all of our processes and our equipment are protected. So that created what is called MERV, which stands for Minimum Efficiency Reporting Value, which means that, okay, so ASHRAE comes along, they say, hey, look, everybody's filtering, but we need to know kind of exactly what we're filtering out. Because if you don't know how efficient your filter is, right, how do you know where to put it? It might be too restrictive because it's too efficient, right? It's taking out too much of the air, right? You can put it in a wall. Wall is 100% efficient. You can't get anything through that, right? So the idea is they came along and they said, hey, we need to have some kind of test criteria in order to determine what the efficiency was. So what they did is they basically create this huge test duct, which will be similar to one that you'll see later today. And they take a filter from whatever manufacturer, plop it in there, and they have this like test dust. They basically put down the air handler or the air duct, and it goes turbulent and blows straight through the filter. And then at the other side, they have a collection point, and they basically collect anything that gets picked up. And based off of that, they determine what the efficiency of the filter is, right? And so with that said, what they end up doing is they end up determining, okay, based off of a certain amount of tests, we go with the minimum value. Meaning you could get like a MERV 8 such as this, right? And it actually performs better than that. But the idea was for people who are out in the field, you need to know exactly what the minimum criteria was that you're going to have in your system. So the worst it does is what it's rated at. So 35% would technically be a MERV 8, okay? And yeah, I already said that. Woohoo! Okay, so with that said, MERV is basically broken up because we're trying to capture the smallest particulate, okay? It's basically rated from 0.3 microns, which is HEPA range, but go with me on this. 0.3 microns all the way up to 10 microns. Now, up here I've got two pictures, right? A strand of spider silk is considered 10 microns. Bless you. Yeah, it's that intense. The Salmonella bacterium, a single cell of Salmonella bacterium, is considered 0.3 microns. That's the sizes that we're working at here, right? So we're looking at the smallest things from basically right on the edge of what your eye can see, all the way down to absolutely invisible. So that's what we're working with. Okay, so I just kind of explained kind of the whole ASHRAE testing thing, and they came out with basically MERV ratings. Now, I put up here 0.3 to 10, but MERV ratings don't go down to 0.3. You're looking at like Hey, Jed, ASHRAE, what is ASHRAE? What is the lowest ASHRAE goes down to? What is it, like, I guess they're still gauging it in 0.3. They just don't necessarily consider that filtered, right? Okay, gotcha. Okay, yeah, so 0.3, basically 0.3 and up is within that range, okay? So MERV ratings obviously are designed to protect certain things. Now this chart isn't exactly perfect, but it gives you a good illustration on kind of what MERV ratings are designed to filter out what stuff. MERV 8 is like pollen and dust mites and things like that. But MERV 13 has kind of some significance over the past couple of years. Anybody want to take a guess? COVID, exactly. Why? Because everyone had to have air quality. That's true. They had to have air. They had to have MERV 13 filters in their buildings. How many people here, and show of hands, how many people had to convert to MERV 13 filters in their buildings during COVID? 3 people. All right. The rest of you are all rebels. I like it. Okay. So yeah, but the reason is because virus carriers, water droplets, things like that viruses can latch onto, are small enough to be captured by MERV 13 filter. But of course, there's a problem. Okay, that is Super Troopers. But what he's talking about is really important. MERV A. Now, before I go any further, does anyone know what MERV A is? Okay, good, awesome. That's why we're here today, right? So, and that brings us to why we buy Camfil. There's one primary reason why you guys buy Camfil, and I'll tell you what. It's because we have the cutest salesman. Just kidding. All right, it's because MERV A ratings. Okay, now normally I would have this video going, but since it doesn't seem to be working, it does not, we will go ahead and jump into it. Okay, so back in 2007, ASHRAE noticed a problem. And the problem was that air filters that were tested, that had gone through the test duct system, that had been given their minimum efficiency rating, weren't holding the efficiency that they were assigned. Meaning, you take a filter, they test it, it comes out, it's a MERV 8, and then it would go in the air handler, disappear, whatever, and it would no longer be a MERV 8 anymore. And the reason is during the manufacturing process, you would get electrostatic media. So the media itself would get charged in the same way that like the computer screen is charged. And basically what would happen is it would be rated at one thing, but then over time, as the fibers in it started getting insulated, it would reduce. And they were like, well, we can't have that, right? We can't have we can't tell somebody like, hey, you've got a MERV 13 in your air handler because of COVID, and it's really a MERV 8. So they needed to come up with new standards. Goodness gracious. So, exactly. So basically you would have things like this, like a MERV 11 actually coming out of the air handler as a MERV 8. And that's a problem, right? Because what was happening was it was referring to its mechanical efficiency. So they needed to develop new testing. And basically what it came down to was they needed to have something that would insulate the fibers. Okay, so they would first run through and they'd say, all right, we're going to run a test on this filter. We're going to do it the traditional method, right? ASHRAE 52.2, some of you guys should be familiar with that. Basically run down the test saying, okay, we got a MERV 8 here. Excellent. Then they would use an aerosol, either on this, I think they use it on a different filter, but they would use an aerosol that would insulate all the fibers. And basically now it doesn't have any electrostatic charge to it anymore, right? It like the balloon, you can't stick it to the wall anymore, okay? And what would happen is then they would test it for real. They would find out, okay, what's the mechanical efficiency? And that's how MERV A was born. What we consider MERV actual. It's the mechanical efficiency of the filter. What it will do when it doesn't have any additional amplification. It's kind of not really the right word, but when it doesn't have electrostatic charge anymore, what does it reduce to? And that's what they ended up coming out with. So here's kind of a good example on what we're talking about. So back in the day when they were doing this test, most things were made out of coarse fiber, okay? Coarse fiber is these large, big kind of things, just like the trees there on the side, right? But since they had the electrostatic charge, they could gather all of the particulate to them, okay? But what happened once all that stuff was going? Well, it was big enough, right? In this particular case, you could put a whole trail down through it, right? It's the same concept. It was dropping in efficiency because there's now just a bunch of pillars that weren't attracting any of the particulate. So a new type of material needed to be born, which is what we use here in like our 3030, which is called, which is a fine fiber material, right? It's smaller, it's denser, it splits. It's designed to capture both small, medium, and large particles. That's the point. So that when you put the filter in, it stays at the MERV rating that it's been tested for. okay? So here's kind of an example. So what would happen was, say you would have like a MERV, I think it's MERV 14 filter that was only used electrostatic media. Over time, it would deplete, it would decrease, and it would basically end up as a like MERV 12 or something along those lines, right? Now, a lot of times during these seminars, I get asked, okay, Josh, that's great. How long does it take before it loses all its electrostatic charge? The answer is we don't know. It depends. It depends on the amount of particulate in the air, the amount of air volume. It's always different, right? For those of you, if you work in an office, the dust that ends up on your screen at your office probably ends up there at a different rate than at home. Well, for those of you who clean your computer screens. But you would probably see a different rate there because there's different particulate and different stuff in the air. So there's no way to actually determine when the MERV rating decreases due to the lack of electrostatic charge. So what that means, though, is that you want to have something that is going to benefit you so that you know exactly what you are getting. And with MERV A, now you have something that's specifically rated for that permanently. It's mechanical efficiency. So even if you get like this dual 9, which is oftentimes comes out of the factory as like a MERV 10, which we don't say that, but like comes out as a MERV 10, you know full well that this is a MERV 9, will go in as a MERV 9, come out as a MERV 9, and it will remove all of the particulate that a MERV 9 should throughout its lifetime. Okay. Next. Okay, so moving on. Why are you buying Camfil? So one of the other things that I wanted to get into is that especially for those of you who are hospitals, right? You guys get inspected by JACO a lot, right? Or at least every couple of years, right? To make sure you guys are doing exactly what you're supposed to do. One of the things that Camfil does is it provides specifically ASHRAE test reports on I believe on all of our filters that specifically to tell you exactly what it's rated at, exactly how it was tested, and what kind of MERV rating it is. So, for example, this isn't one of ours, but this is kind of an example of what a ASHRAE test report looks like. Okay, this one was rated as a MERV, I think, what is that, MERV 13, MERV 14, okay, and then it turned out to be a MERV 11A, okay, so that's basically what these folks who put that in, who went through the testing process, went through that. At Camfil, we make sure, right, that if you are utilizing our product, you can get this data so that you know exactly what it is. So if somebody ever came to you, if you have any kind of inspection, it will tell you exactly how this filter performs in the air handler, right? It covers everything from air volume efficiency. So basically how it does as the air volume or air velocity increases. It tells you how it does when loading curve, right? How it does as it loads up, basically. What's it going to look like, which is really effective for energy savings. It also tells you what particulate it will filter out and in what efficiency that way. The whole point of it is specifically so that you have all the specific knowledge that you can take to any, your boss's boss, the federal government, whoever it is, so that you know exactly what's running through and what kind of air quality you get. Okay? Right here. I'll just give you one. All right. What's the other reason why you guys buy Camfil? Well, the other reason you buy Camfil, which is probably the big one that we harp on all the time, is longevity. Okay. So we utilize a high lofted media, which is basically the fine fibers that I was telling you about, that's specifically tight woven in a certain manner in order to effectively prevent all the particulate from getting through. Okay. As you can see, kind of as a comparative here, this is our Camfil 3030, and then I believe which would be this thing right here, Camfil 3030, and I believe that's a cross-section of a competitor's product, which I believe is Renza, but I'm not entirely sure. But you can see right off the bat, right, just the difference in overall volume. Part of the reason why Camfil lasts longer than everybody else is not because I want it to. Not because I'm such a good salesman I can convince you to. The reason is because ours operates a lot more like a bucket. We have volume. There's plenty of filters out there that have the exact same square feet of media as ours. But what they don't have is the volume of media. And that's what allows it to collect. And I'll give you an example. So radial pleats. So part of the reason why it can do that, right, why it can collect so much is because it has these radial pleats, these buckets of material. Now, when I was developing this, I was building this on Adobe Illustrator. Yes, I'm an artist. Basically what I was doing is I just created these two designs just as an example, okay? And just by happenstance, I started filling up the little black dots there in the filter media. And I did a certain amount, and then I filled up the other side. And just for the heck of it, I decided I would put another set of dots down there. And as it so happened, I was able to put twice as many dots in the radial pleats as I was in the convex pleats. So the idea is just simply because you have a rounded edge, you basically have kind of more of a bowl shape. It allows it to collect more particulate in the air. Welded wire backing. Okay, part of the other reason for the longevity is the welded wire backing. So Camfil's filters, their pre-filters specifically, are designed to go up to 2 inches of water column. So we don't recommend you go that high, but they are designed to go that high because of the welded wire spine that basically lines the back of it. We normally recommend, for those of you who use the product, we recommend what we call double the initial pressure drop. Okay, so basically that's the most efficient place where you basically, after that, the amount of money you're spending on energy is going to be more than what you would just getting a new filter. That's usually what we recommend, is double the initial pressure drop. So what I mean by that is you put the filter into the air handler, right? You read the magnehelic, or if you're a Boulder Valley School District, you try your best to put the, I'm just messing with you, Brandon. You put basically a digital magnehelic across the filter bank, and then you take that reading. When that doubles is when we recommend you normally change out your filters, okay? And that's just specifically because if you don't have, once you get past that, the energy cost is greater. So, but with that said, let's just say you can't. I work with a bunch of mines up in Wyoming that they get beaten up, right? They're changing filters so frequently. I think they change ours once every 3 to 4 weeks. So the reason is so they don't have the ability to go in and make sure that they are filtered it's exactly efficiently. So they take theirs all the way up to 1 inch. So the idea is that if you have to do it, if you can't do it, or some reason, your HVAC guy is out sick, right? These will filter all the way up to 2 inches, which is a long time. This starts at 0.3. We recommend you change it out at 0.6. So you have a nice big gap, right? But as I said, we don't recommend it, but that's part of the reason, is the fact that they're very sturdy. They're designed specifically not to collapse. Now, one thing I want to point out here, can somebody tell me something unique about that picture, on why that picture is the way it is? And maybe some of the reason why we're getting some rigidity. Any ideas? Yes, because the pleats are vertical, right? So like anything else, right? Pleats operate kind of like columns in the Parthenon or something along those lines, right? Or even columns in a building. They help keep everything rigid. As air is blowing through it, yeah, perfect. Jed's going to hand out kind of the combination of the two different types. But basically, it's a lot harder to break this going this way than it is to go this way, right? This is more like an accordion. Now, it still has its protection, right? But the thing, though, is we always recommend, if you can, which sometimes you can't, we always recommend you put it with the pleats going vertical, because it will last longer. And at the same time, if you get any water or anything like that, it drains to the bottom rather than sitting and cooling on top of the pleats, okay? Lastly is high-strength beverage board. Basically, I'm not going to go into too much detail. Basically, it's just really strong painted cardboard that's designed to get damp. It can't get soaked, but unlike regular cardboard that will shrivel up and die on you, it's specifically designed. This filter right here, the Dual 9, actually, it's hydrophobic, and I've actually seen these get wet and then get put back into the air handler and work just fine. That's the way that it's designed. They're not designed to get soaked, but they are designed to get wet, rain, snow, that kind of stuff. So, all right. That's why we're better. Yay. All right. Last one. Okay. Just for the sake of time here. Okay. So the last reason why you're buying Camfil, if you are buying Camfil, is because of our guarantee. So we guarantee all of our filters. So for example, I've got one for the 3030 here, and I think I've got some for the Dual 9. But basically, we guarantee that if we do not beat the competitor, right? If there's anybody else that you're using, if we do not beat it, then we will give you your money back on what you bought from us. Right? The whole idea is that we want to put our money where our mouth is, and so if we can't outperform anybody, then we are willing to pay for it. Right? The idea is that we are so confident in our product that we're not concerned about anybody else out there. So with that said, I have both guarantees, ASHRAE test reports, and anything else available up here at the booth. But that is it for me until we do the cam tester. Any questions? I just wowed all of you that much, huh? Come on. Anything? Okay, for those of you who walked in a little bit late, just so you're aware, if you stick around to the end and you do the Jeopardy thing, you have an opportunity to shoot a Gatling gun. So just letting you guys know. I'm looking at kind of a general amount of you guys. So, all right, guys, well then if that's the case, we're going to go ahead and take a 15-minute break. We're going to set up the cam tester outside, and you guys are welcome to come and check it out. And then after that, we're going to go to our belt man, Tim. So. Are they asking questions?
They haven't asked any questions, but do they know that we're on a break?
Yeah.
You're not going to see anything.
Yeah, I've already sent them all the times.
It's pretty good. We had like 25 on average.
Okay.
Independent viewers. So now I imagine there's multiple people in the audience.
Nice. Perfect. Okay.